from MCA 5 years course 5th Sem B section. In this video, we will solve the 5th semester and some examination from question number 7 to question number 9. So the question number 7a says, explain the k-means clustering algorithm with steps. Discuss how initial centroids influence result. And the B part is completely demonstrate the illustrating algorithm and compute a KNN classification example using Euclid's distance. So the 7th A is k-means clustering algorithm. So the k-means is an unsupervised machine learning algorithm that partitions and distant point into k distinct cluster, ensuring that points within the same cluster are similar. Then the steps for the k-means algorithm are first initialization, that is first specify k, decide the desired number of clusters, initialize centroids, that is randomly select k data points from the dataset to serve the starting cluster centroids. Then assignment step, that is each step expectation. So calculate the distance between every point xi and all k centroids. Assign each data point to the cluster C of j whose centroid nu of j is the closest. Then use the mathematical assignment in this way. Then update steps with m step maximization, that is recalculate the position of each centroid by computing the mean of all data points currently assigned to that cluster. New centroid calculation is calculated by the new centroid, that is nu of z nu for cluster C of j, and the formula is this. Then the conversion check. So repeat step 2 and 3 until the cluster assigns no longer change or the centroid stabilizes or a maximum number of iteration is reached. Then influence of initial centroids. So the initial selection of centroids significantly impacts the final result. So first is local versus global minimum. The K means minimizes the within cluster sum of square. Poor initial placement can lead the algorithm to converge to a suboptimal local minimum instead of a desired local optimum. The second is cluster quality. So if initial centroids are poorly separated, then the resulting clusters can be skewed, imbalanced, or fail or to accurately reflect the natural grouping in the data. Then mitigation, the standard solution is to run the k-means algorithm multiple times with different random initializations and choose a clustering with the lowest final WCSS. Then the B part of the seventh question is demonstration of k-means clustering and k-nearest algorithm. So there are four data sets that will be clustered into k is equals to two groups. So points are P1, P2, P3 and P4. Feature is X1 and the feature is X2. Then this first step is initialization. So we will initialize with 1 and 1 and nu2 is equals to 1.5 and 2. Then iteration 1 is assignment and update. So point Pi is P1 1 P2 1.52, P3 goes like 3.3 and 4 and P4 goes like 5 and 7. Then we will calculate these all values from the formula mentioned before. Then the resulting clusters are C1 that points to P1, C2 that points to P2, P3 and P4. Then new centroids are new 1 new and the values are 1 and 1 and the new 2 new values are approximately equal to 3.17 and 4.33. Then iteration 2 assignment and update. So the points are given as this and we will calculate d square, then d square of from pi to nu 2, then assign cluster. Then the resulting clusters will be like C1 and C1 to P1, C2 to P2, P3 and P4. And the points will be like from this to 1 1, then 1.5 to 2, 3 to 4 and 5 to 7. Then the k nearest neighbors classification example. So KNN is a supervised learning algorithm that classifies a new data point based on the majority class among its k nearest neighbors in the training data. The training data is points at T1 to T5. X and Y values are given. We will find the class. Then the query point q is equals to 6, 6. So parameters we have k is equals to 3. We will compute the equivalent in distance using the formula under root of x1 minus x2 whole square plus y1 minus y2 whole square. We will put the values of all the points and will calculate the Euclidean distance for all the neighbors. Then the step 2 is identify the k is equals to 3 nearest neighbors. So we have T3, T2, T5. So classes class B and class A. The third step is to determine the class majority vote. So the class A is 1 vote and class B has 2 votes. So the conclusion is the query point, that is Q6, is classified as class B by the KNN algorithm with k is equals to 3. Moving on to the question 8. So the question 8 says compare decision trees, random forest and boosting, highlighting strength and weaknesses of each. The B part is show how basic logic gates can be built using single layer neural networks. Complete table. So the table is given like this, and here the data is not given. We need to find the data. So the algorithm we will use is first is decision tree, which is easy to interpret. Then we have random forest, which is highly accurate. Then we have bagging ensemble, which is effective on large databases. Then we have boosting, which often produces the best predictive accuracy. Then we have boosting and ensemble, uh, which can effectively identify and fix errors made by weak learners in previous steps. So these are the steps of these algorithms. The weaknesses are so in decision tree we have prone to overfitting, high variance, and finding the globally optimal tree. Then in random forest we have less interpretable, more expensive, and can be biased towards features with more categories. Then in boosting, we have highly sensitive to noisy data, longer training time, and tuning of hyperparameters. Moving on to the B part of question number 8. So, building basic logic gates using single layer neural networks. Single layer neural networks, especially perheptrons, are perfectly modeled linearly separable functions like and or not. The XOR function, however, it is linearly separable and cannot be implemented by a single layer spectron. The following table summarizes the requirements from implementing these logic gates with a single layer neural network. Now, this is the table. We will complete this table. So, the gates are AND or not and XOR. The number of neurons in AND are 1, then OR in 1, and in NOT we have 1, and in XOR we have requires 2 layers. So, we have 2. So, then activation function for AND we have step, and then in OR we have step, and NOT we have step, and in XOR we have step or sigmoid or ReLU. Then in back propagation needed, so in and it is not needed, in OR it is not needed, in NOT it is not needed, and then in XOR it is needed because it requires training via back propagation. Now the explanation of implementation. So AND gate example, linearly, which is separability. So a single neuron can implement the AND function in which we have inputs as x1, x2, 0 and 1, weights we have w1 and w2, in which both the values are 1, 1, and bias we have let b is equals to minus 1.5. Then activation function we have step function where output is 1 if net is greater than 0 and 0 otherwise. Then in net input we will put the formula, that is net is equals to w1x1 plus w2x2 plus b. So which comes out to be in B we will put minus 1.5. Then in this we will put the formula of x1 and x2. from this table. So the output comes to be 0001. Now, since the net is positive only when both x1 and x2 are 1, the single neuron successfully implements the AND gate without complex training. Then XOR gate non-linear separability. So the XOR function is non-linear separable, meaning no single straight line can be drawn or a 2D plane to separate one outputs. That is 0, 1 and 1, 0. From the 0 outputs, we have 0, 0 and 1, 1. Therefore, it requires a multi-layer perceptron, that is MLP, with at least one hidden layer. Now, moving on to the question number 9, that is the last question of the end semester examination. So, the question number 9A is calculate information gain from age, income, student, and credit rating attributes. Find which attribute gives the best RST split, that is highest gain. And the B part says calculate Gini index for all attributes of 9th A question. Also find the best RST split and build the complete decision tree. And the C part is draw two decision trees, that is one from information gain and the second is one from Gini index. So in this we will take age, then income, then student, then credit rating and the bias computer. This is the chart which is given in the question. So the first is root node summary, that is total attendances is n is equals to 14. Class says yes is 9 and class says no is 5. So in the first part, information gain calculation, that is ID3 algorithm. So in this, information gain measures the reduction in entropy achieved by splitting the data on a particular attribute. The split with the highest IG is chosen. So the initial entropy of the parent node E of S is calculated, which comes out to be approximately equal to 0.940 bits. The second is information gains for each attribute. So gain of 1, we will use this formula to calculate the information gain for each attribute. So the first for age, when we will put the values in this, we will get as 0.246 bits. Then for attribute credit rating, we will get as 0.048. Then the conclusion for 9th A, that is some information gain, is like attribute age has information gain of 0.246 and income has 0.029 and student has 0.151 and in credit rating we have 0.048. The attributes age gives the highest information gain as 0.246 and is the best choice for the first split root node using the ID3 algorithm. Moving on to the part B of ninth question. So Gini index calculation, that is CART algorithm. So the Gini index or Gini impurity measures the impurity of a node. For splitting, we calculate the weighted average for the Gini indices of the resulting subsets. The split with the lowest weighted Gini index or highest Gini gain. Gini gain is equals to Gini S minus Gini split of A is chosen. Initial Gini index of the parent node, that is Gini X, is calculated using this formula, which comes out to be approximately equal to 0.459. Now the second is weighted Gini index for each attribute split. So we will use this formula to calculate Gini index for each attribute split. So attribute A has Gini split age of 0.343. In income we get as 0.440. For attribute student we get as 0.368 and the attribute credit rating we get as 0.428. So conclusion is we have age as 0.343, income as 440 and student as 0.368 and credit rating as 0.28. So the highest Gini index, weighted Gini index is of income, that is 0.440. Now the attribute age gives the lowest weighted Gini index, that is 0.340 and is the best choice for the first place root node using the CAST algorithm. This is consistent with the information gain result. Third is building the complete decision tree using root as age as root. Since both matrices selected age as the best split, we use it as the root. So the node 1 is root split on age. So age is equals to 31 till 40. 4 yes and 0 no. Pure leaf node bias computer, that is yes. Then age less than equal to 30, in which we have 2 yes, 3 no. Impure mode, so subset is as 1. Then in age we have age is greater than 40, which is 3 yes and 2 no. So impure node, so we have subset of S2. Now the node 2 splitting S1. So age we have less than 30, where 5 instances are 2 yes and 3 no. We calculate gain A and Guinea split A for S1 using the remaining attributes. Income, student, credit trading, where E of S1 is 0.971 and Guinea of S1 is 0.480. The attributes are student, income, and credit training other than age. So bad split is student we have 0 and income we have 0.480 and in credit rating we have 0.400. Then student gives the perfect split, that is Gini index is equals to 0, where student is equals to yes, 2 yes and 0 no. Pure leaf mode is yes, student is equals to no, where pure leaf node is no. Then the node 3 is splitting S2, that is age greater than 40, where 5 instances are 3 yes and 2 no. So we will calculate the gain A and Gini split A for S2 remaining using the remaining attributes of E of S2 is equals to 0.971 and Gini of S2 is equal to 0.480. So the attribute we have credit rating, income and student other than age. So the best split is lowest Gini. So we have 0.320 for credit rating. Income we have 0.480 and student also we have 480. So the credit rating gives the best split. So the credit rating is equals to fair, where 3 yes and 0 no. Purely if not becomes yes. And credit rating is equals to excellent, where 0 yes and 2 no. So pure leaf node becomes no. The C part is drawing the decision tree. So decision tree 1 is using ID3 and card tree. The tree is built using the best attribute choice at each level, highest IG or lowest Gini index. Root node is age, branches from 31 to 40, leaf is yes. Where branch is less than 30, we have node student. Then branch greater than 40, we have node credit rating. The decision 2 tree is based on arbitrary different initial split. Example student. If we were forced to start with student as the root, the tree would look different. So the root node student, where branch is yes, the branch credit rating is fair, and the branch credit rating is equals to excellent, where 3 yes and 1 no are used. Then the branch no is 3 yes and 4 no, where impure nodes. So the best split for S4 is age, where Gini split is equals to 0.286. So it was all the questions are discussed.